Hello student, we already learned in last topics are variation in G with altitude and depth. Now our next point is variation in G with latitude and rotation of the earth. Now this is the earth rotate with its axis. Rotate with axis with a constant angular velocity omega, and this is the equatorial point, is the line is the E, and P where situated a point. So body placed at point P on the surface of the earth and making an angle, it's called theta. This is the latitude. The body is placed at the point P, moves along the circular path whose center is O dash and radius is small r. So O dash P is equal to r. The angle of EOP is equal to theta, E being point on the equator. So O dash, this is the angle also theta. So this is the capital R is the radius of the earth, and the small r which gives the distance from axis to point where situated a body on the surface of the earth. So we know that PO dash is equal to R, so angle EOP is equal to theta, and therefore angle of OPO dash is equal to theta. So in triangle OPO dash, now this is OPO dash, this is the angle PO dash is equal to theta. So in angle O triangle OPO dash, cos theta is equal to PO dash upon PO is equal to small r upon capital R. So we get here small r is equal to capital R cos theta, and the centripetal acceleration from the mass M directed along PO dash is, now we know that the PO dash is the PO dash, and this is directed in the direction here toward the center. So this acceleration is called a radial acceleration because it's toward the center of the circular motion. So here A is equal to R omega square. This is the relation between acceleration omega, angular velocity, and distance r radius. So small a is equal to, put up the value of small r, this is the r cos theta, so r cos theta, and this is the r omega square. So the component of this centripetal acceleration AR is equal to, because this acceleration toward the center of the earth, so this is called the centripetal acceleration. So AR is equal to small a cos theta. Therefore AR means centripetal acceleration. It's also called a radial acceleration because it is toward the radius. So therefore AR is equal to R omega square cos theta into this is the cos theta. Therefore AR is equal to R omega square cos square theta, and effective acceleration G dash due to gravity at point P directed towards center of the earth is, now here G acted on the any object in the surface of the earth, so we get here work done means mass, where mg dash means weight, is equal to So mg dash is equal to mg minus mr omega square cos square theta. So cancel out, then we get g dash is equal to g minus r omega square cos square theta. As the value of theta increases, cos theta decreases. We move away from the equator towards any pole due to the rotation of the earth. So this equation means g dash is equal to g minus r omega square cos square theta. This is the final equation of acceleration due to gravity. It's variation in g with latitude. Now special case. So case first. So at equator theta is equal to 0. Equator means is the central line. So this is the equator line. So at equator theta is equal to 0 because this point is situated on equator. So no angle made by this equator line. So here theta is equal to 0. Then we get cos theta is equal to 1. So we get equation of the latitude g dash is equal to g minus r omega square, because cos square theta is 1. So we get here 1 also. G dash is equal to g minus r omega square. So effective acceleration due to gravity is minimum at equator, as here it is reduced by maximum amount. So the reduction here is given g minus g dash is equal to r omega square, and the value of the radius of the earth is r is equal to 6.4 into 10 raised to 6 meter, and omega is the angular velocity. So we get a formula for omega is equal to 2 pi t. So omega is equal to 2 pi, and t means 24 hours into 60 into 60. So we get omega is equal to, then we solve this equation, then we get 7.275 into 10 raised to minus 5 meter per second. So therefore g minus g dash is equal to r omega square, and the value of putting the r and value of omega, then we get the final equation, and this gives the difference between reduction. It's g minus g dash is equal to 0.03386 meter per second square. So now special case second. So at poles theta is equal to 90 degree. Again see the figure. Now at point when theta is equal to 90 degree. So at poles, this is the possible. This is 90 degree. So theta is equal to 90 degree and cos theta is equal to 0. So we get the value of g dash is equal to g minus r omega square cos theta. So therefore g dash is equal to g minus r omega square cos square. These all terms are constant. So we get here equal to 0. And so g dash is equal to g. Effective acceleration due to gravity is exactly equal to acceleration due to gravity.